welcome to NDSU. I'm Mary Page and I am a Master's of Environmental Engineering student here. I'm going to introduce us. First of all, we are in North Dakota, right by the star. You can see our slides, I'm not sure. It's up in the northern part of the United States. It's still cold here, we got snow yesterday. North Dakota is a land-grant university. It's got about 13,000 students, and we're ranked 108 in public research universities by the Carnegie Mellon Commission. Our department alone has about 66 graduate students this year, and that's been about where we've been for the last 3 years. This year we have over $6 million in grants to perform research. Our journal publication activity in our department is around 65 to 68 in the last couple of years, and we've averaged about 40 overall for the last decade. So today we're going to have several presentations by undergraduates. We're going to start out with one from NDSU and talk about nanoparticles. And then you guys are going to give one, and then we'll give one, and you guys will give one. And I think we're going to go to Laura now.
No, they are going to present in that side.
Oh, I guess you're going first. Never mind.
Sorry. Yeah, I think there's a welcome thing. They are presenting from that side.
We're ready if you guys are for your welcome.
Good evening, everyone. On behalf of the students and the faculty members of Assam Engineering College, I, Rimjim Kashyap, welcome everyone to the first digital conference between North Dakota State University and Assam Engineering College. I would like to first introduce you to our motherland, India. India is a land of cultural diversity and natural beauty. India's astounding diversity of religions, languages, and cultures is unique and unparalleled. The society of the vast subcontinent, varied and complex in its rich heritage, is among the oldest in the world. Nestled beneath the Sub-Himalayan range of hills in the northeast of India lies the state of Assam. Assam is known as the Shangri-La of northeast India. Assam is a state which is rich in natural beauty. A chain of hills adorns Assam. And the mighty Brahmaputra, along with the Barak, has been nourishing the state since time immemorial. The green forests of Assam have a distinct beauty with their tall trees, shrubs and bushes. The capital of Assam is Dispur. The culture of Assam is very rich. The perfect fusion of heritage, tradition and faith and beliefs of numerous races has resulted in many festivals in the state. The main festivals of Assam are the Bihus, which are celebrated all over the state by everyone with pomp and grandeur. Assam is famous for the one-horned rhinoceros. Kaziranga National Park, situated in the Golaghat and Nagaon districts, houses world's largest population of one-horned rhino. Other wildlife sanctuaries like Manas and Pobitora also houses rhinos. Other animals found in Assam are the Royal Bengal tiger, golden langur, etc. Many migratory birds also visit the state of Assam in all seasons of the year, especially during the winter season. One of the most prominent locations of migratory birds is the Diporbil. Diporbil is a permanent freshwater lake in the former channel of the Brahmaputra river to the south of the main river. It is located to the southwest of Guwahati city in Kamrup district. It is considered as one of the largest beels in Brahmaputra valley of western Assam. In the vicinity of Diporbil, our esteemed college, Assam Engineering College, is situated. Assam Engineering College was established in 1955 and is located in Jalukbari in southwest Guwahati. It is a premier technical institute of Northeast India. The college is approved by All India Council for Technical Education (AICTE). The college offers bachelor courses in the fields of civil engineering, electrical engineering, mechanical engineering, chemical engineering, electronics and telecommunication engineering, computer science and engineering, instrumentation engineering, and industrial and production engineering. It also offers master's courses on computer application, MCA, civil engineering, electrical engineering, and mechanical engineering. All the courses are affiliated to Guwahati University, the education hub of Northeast India. I would like to thank North Dakota State University for collaborating with us in this little effort of ours. We hope that we can continue it in the years to come. Thank you.
Hello, my name is Laura Clarence, and I'm undergraduate research assistant for Mary Pate with NDSU Environmental Engineering Lab. Today I'm going to be speaking on surface modification of iron nanoparticles for groundwater remediation. First of all, I'd like to thank National Science Foundation, Civil Engineering Department at NDSU, Nano Environment and Virology Research Group, Mary Pate, who I work with, Dr. Sonoy Simsek, Dr. Cynthia Besbora, NDSU ITS, as well as Assam Engineering College. This graph here shows the 2015 projections of spending for US dollars on different nano markets. Includes materials, electronics, and pharmaceuticals as being the high costs, as well as chemicals, aerospace, sustainability, healthcare, and tools. Nanoparticles are less than 100 nanometers, and they are metallic, so they come from gold, iron, nickel, or cobalt. They're semiconductors, and they're polymeric. Nanoparticles for the environment. Remediation includes soil, water, as well as air. We use them because it increases surface area, it provides faster reaction rates, and in the end, products are benign. So the particles are less than 100 nanometers and is a potential reducing agent. Many environmental contaminants are susceptible to reduction reactions. Some pros for them that they're easy for subsurface injection, they're highly reactive surface area, and they're non-toxic as well as inexpensive. This shows some of the different chemicals that are either reduced or absorbed by the NCVI particle. So you can see that the orange core around it is the oxidation. Limitations on NCVI include that it has low dispersion and then it tends to agglomerate, and which the agglomeration then reduces the surface area. So they're also non-selective and it oxidizes easily. This
You should call back.
Okay.
Ekkuno porimaano দুটা বস্তু থাকে অলপ সৰুৰ পৰা বছ গুড 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 নো নিড টু চেঞ্জ সেইটো ইংলিছ কৰা সেইটো ওপৰত থাকে সেইটো কিছু ঠাই দিয়া নাই
Can you see and hear us okay? Can you see and hear us and see our slides?
Yes, sir, you can continue, please.
All right, continuing with the conceptual design, this shows an NCVI particle that's been coated. The red kind of triangles bind the coating to the NCVI particle, kind of like a swimsuit, and then the legs help it swim through. The ultimate goal is that the NCVI will be selective in which chemicals that it reacts with, shown in the other diagram with the yellow. Amphiphilic polysiloxane graft copolymer, or APGC, is something that SIDA has been working with. The objective is to modify nanoscale zero-valent iron particle surfaces using APGC for effective groundwater remediation. Our design, the synthesis of APGC, as you can see there. These graphs show the colloidal stability studies that have been used. The dotted line shows that the coated NZVI has been more effective in staying suspended. The blue on the graph shows that the bare NZVI is less effective. TCE and arsenic removal by coated NZVI. These are graphs that show the concentration of the chemical once it's been treated with NZVI, both bare and coated. The coated NZVI has been more effective than the bare NZVI. Hajri has been working with soybean oil-based graphed copolymer, or SOGC. The objective is the synthesis of biodegradable amphiphilic copolymer from a soybean oil. This is the synthesis and some of the vials that have been shown in that testing. These are some sedimentation studies that have been used. The graph shows that the bare NZVI in the green was much less effective, and the vials show the suspension after a certain amount of time, so initially as well as 15 minutes later, an hour later, as well as 2 hours later. So as you can see, even after 2 hours, the coated NZVI is more effective in staying suspended. In summary, the APGC has pros and cons. It's effective at improving suspension of NZVI, and it increases TCE removal. However, it's not biodegradable, and it has a complex synthesis process. Soybean oil-based SOGC has a pro because it's natural polymer, and it's biodegradable. However, it also has a complex synthesis process. Starches for coating, I've specifically been working with this. The starches that we use are wheat, rice, tapioca, and maize. We use this because it's biodegradable in aquifer. Sedimentation screening studies. These show some of the vials that have been used for different purities of the starches. Even after 2 hours, you can see the difference in between bare NZVI versus 1 gram per liter, 5 grams per liter, or 10 grams per liter of a coated particle. This again shows some of the NZVI sedimentation studies, pictures showing the bare NZVI compared to different coatings after sonication. Specifically shows the 10 grams per liter. This graph represents how the bare NZVI stays suspended differently compared to a coated starch, such as the modified tapioca starch or unmodified even. As it shows, bare NZVI is less effective in staying suspended. Our future work will include TCE degradation studies, a sticking coefficient. With the sticking coefficient, the goal is for the NZVI not to stick to sand or other materials. We'll also work with column studies, horizontal flow studies, including permeable reactive barriers. The picture shows that how groundwater will run through a certain barrier that will include NZVI and ultimately come out as treated groundwater. This is our nano team. Thanks for listening to my presentation. Any questions? You can ask now.
Any questions? You can ask them again if they have any questions.
Do you have any questions?
If I have any question, then you may ask me.
Were there any questions?
Write on a
Yeah.
board and
Maybe I can speak with it loud.
yeah.
Do you have any questions from the other end for Laura? Do you have any questions for Laura?
No, sir. No, sir. We don't have any question. Thank you for the presentation.
Go for the questions at the end as well. Okay.
Okay. So we'll be proceeding with our presentation now.
Sure.
So it is Bhanupriya Kolita and Meenakshi Guhai from Chemical Department.
Okay, sorry.
Mute their video.
Yeah, I
Because if you can see their slides, that's all you need to do.
oh, sure, yeah.
Disconnect and reconnect. If she's not paying close attention, she may just talk.
Yeah, yeah. Yeah. Okay.
Yeah, they would know it. We don't need to see them the entire time. They can just
They have not realized that they're disconnected. They're speaking on that.
Yeah, I'm not sure you're meeting them. I really came sequence. Yeah.
Let me see. still see their slides?
Oh, yeah, absolutely. If you unmute the video, when they introduce themselves with the speakers,
Oh, okay.
the speaker,
Okay.
then they just have to click the mute video.
Oh, okay.
They'll still see the slides.
Oh, okay.
Okay, sure. Upload the video.
Months ago, we highlighted very well. What we did was we closed that. We used our Chinta was there. It was easier to communicate. I was able to do from home. Not Skype, but using the software which I use here. They did a copy of the same software installed. Right, so then it is, because it's better than Skype. With India, it is not very good. I think this technology is being launched as general manager for L&T. They have every with their offices in California. And it's very smooth. Very, very smooth. No technical difficulty. I think I've figured out their powers.
Okay.
Yeah, they probably do. They should not see that the lower.
If you are disconnected, we are not getting your video. We have been trying to send you Skype. You are not responding. So you have to reconnect and also hold on for a minute. Daniel will tell you a little bit more.
Sometimes it works. Most of the time,
Connection is not able to do the video and audio. So when you connect, can you please mute your video? Basically, click on the camera symbol on the window. That way, we can still hear you and see your computer screen. You don't have to upload the video. So go ahead and mute your videos. If you want to introduce the speaker, you can unmute the video. See the speaker, and then you can mute it again. That should be better for the connection. Hello? Hello? Yeah, are you having problems reconnecting? Okay, yeah, go ahead and call our number again. What's on the screen now?
the Samantha, you look all stressed out.
Oh no.
You're good, you don't have to practice anymore.
Stops at different times. Let's say it's right? I don't know how their connection works. If they would mute their video, it should be much easier for them. Now it's not. Like,
Can you see and hear us?
Yes, we can hear you.
Okay, if you want to go ahead and mute your video, so on that screen where you see our video, there should be a little camera symbol. If you click on that, it'll stop your video, but we can still see your computer once you share it. You want to go ahead and click on that little camera symbol on the screen?
Can you hear it?
It should be at the top of the window where you see our video. There should be a little camera symbol. Just click on that and then select none for the camera.
Okay. So should we represent the first slides?
Oh, go ahead and mute your video first so that the connection's not going to disconnect again. So go ahead and click on the camera symbol on the top of the screen there, and then select none for the camera.
Okay, Megam, there's a small symbol of camera on the top ribbon. Mute that one. You can still share your screen. We'll not see your video, but we'll see your presentation. Because with both of them, that your connection can't handle it. So you need to send only one. So go ahead and mute the camera, video on the ribbon.
Okay, so can you play the slides that we have sent to you?
You can still share your slides. You just need to mute the video.
Can you first mute the video?
Okay.
Go to the ribbon and mute the video.
Don't host the mic.
They clicked on the mic.
There we go. Okay. And now
okay?
you can share your content. Yeah, perfect. So now go ahead and share your presentation.
Okay. So should we start from the first?
Yeah, start from the beginning because we didn't hear you from the beginning. Yeah. Can you share the content now?
Yes.
Yeah. I told them.
Sir, can you hear us?
Yeah, we can. Yeah, you can go ahead.
Yes, we can hear you.
Respected faculty members of NBSU, students, and one and all present. Greetings from Assam Engineering College. And good evening to respected teachers and one and all present here. To begin with, let's move to our first slide, Introduction. Well, among all the hazardous components found in industrial effluents, synthetic coloring agents, dyes, can be considered as one of the most adverse unwanted material. Even at a very minor concentration, presence of dyes and pigments are not desirable. More than 10,000 various kinds of dyes are commercially available, which finds its use in many industrial processes. Dyes are produced at a rate of 7 into 10 to the power 5 to 1 into 10 to the power 6 tons per year, and to our concern, 10 to 15% of that amount enter into our natural environment. The result of the dumping of colored effluents into our aquatic ecosystem leads to both environmental and public health risks by bioaccumulation in wildlife. Under aerobic conditions, many dyes can decompose into carcinogenic aromatic amines, which cause serious health hazards to humans and animals. Moreover, it causes allergy, dermatitis, skin irritation, and even cancers in humans. Let's move to the next slide. Purpose of study. Why we are dealing with removal of methyl violet. In our paper, we are dealing with methyl violet dye. Methyl violet dye is employed in textiles, fabrics, for coloring the materials. In printing and paint industry, this dye is also used. The medical community apply this dye as a biological strain, and is also an important ingredient in gram staining. The dye is applied as an external skin disinfectant in humans. Methyl violet is a protein dye in nature, and so it also finds application as an enhancer for bloody fingerprints. But it has negative aspects too, like causes moderate eye irritation and also highly toxic to mammalian cells. In extreme cases, it may also lead to respiratory and kidney failures. Next, advantages of biomass. There are many conventional ways of removing methyl violet dye, but we are dealing with biomass because they have other methods have disadvantages like incomplete removal, high reagent, generation of toxic substances, etc. Adsorption has emerged as an efficient and cost-effective process. It's a process where material gets added to the solid substances. There are many natural elements which can be used directly or indirectly for the removal of methyl violet. In an attempt to develop an inexpensive adsorbent for removal of methyl violet, biomass was chosen. To our best knowledge, there is no still report about the use of sulfuric acid treated biomass as an adsorbent for methyl violet removal. Next, we are using bamboo biomass, or the advantages of bamboo mass. Well, the bamboo has the fastest developing land plant in the world. A bamboo stump can renew itself in just 50 days, and it produces 35% more oxygen than any other stump or branches. It can absorb 3 to 4% more carbon dioxide than any other stump or branches. The bamboo biomass is also an inhibitor of soil erosion. Next. The materials and methods. In our study, we washed the bamboo biomass repeatedly with double distilled water and dried at 343 Kelvin for 24 hours. The dried biomass was expanded in 5% H2SO4 and filtered off until it was close to neutral. And then the biomass was used for the experiments. Stock solution was prepared by dissolving accurately weighted quantity of the dye in double distilled water. Next, the batch experiments. The batch experiments were carried out in 250 ml glass toppered enveloped flask with a working volume of 100 ml with an initial concentration of 50 mg per liter. The influence of various process parameters like pH, initial dye concentration, contact time, adsorbent doses, and temperature were calculated. The results were taken 3 times and the mid value were taken as the final results. The results will be discussed by Ms. Bhanupriya Das.
First of all, we discuss the effect of pH, keeping the other 4 parameters, namely adsorbent doses at 5 grams per liter, the initial concentration at 50 ppm, temperature at 30 degrees Celsius, and contact time of 3 hours. We varied the pH from 2 to 10, and on plotting the graph of percentage removal of dye versus pH, we have obtained an increased trend in the dye removal with an increase in pH. The maximum at pH equals to 8, which can be attributed to the fact that increase in the hydrogen ions at low pH gives a tough competition to the methyl violet dications for appropriate sites on the adsorbent surface, while at high pH, reduction in the hydrogen ions Sir, can you hear me?
Yeah, we can. Yes, we can hear you.
Thank you, sir. With the increase in pH, the reduction in the hydrogen ion provides better avenue for the methyl violet dications to replace the hydrogen ions and thereby bind to the surface of the adsorbent. Next, we have the effect of adsorbent doses. Keeping the other 4 parameters constant, we have varied the adsorbent doses from 0.5 to 10 grams per liter, and we see an increasing trend in the removal of dye percentage with the increase in the adsorbent doses. This is mainly because of the increase in the surface of the adsorbent and increase in the active sites. Next, we have the effect of initial dye concentration and contact time. Adsorbent rate is a function of the initial dye concentration, which makes it a very important factor to be considered for effective adsorption process. We varied the initial dye concentration from 10 to 100 ppm and kept the other parameters constant. We can see a decreasing trend in the removal of the dye with the increase in the initial dye concentration. This is mainly because of the saturation of the active sites of the adsorbent. But secondly, we have the adsorption capacity increasing at equilibrium with the increase in the initial dye concentration. This is because of the increase in the driving force, mainly the concentration gradient, which overcomes the resistances offered in the mass transfer from the aqueous phase to the solid phase of the methyl violet dye. Further, we carried experiments of the effect of contact time, and we found that for a contact time of up to 120 minutes, the dye removal was maximum. It achieved equilibrium at 180 minutes, but a further increase in the contact time did not enhance the adsorption process. This is because at early stage, the rapid adsorption is because of the diffusion from the bulk to the solid phase, while at the later stage, this absorption became only an automatic control process with the decrease in the absorption sites. Lastly, we have the effect of temperature. We varied the temperature from 300 to 335 Kelvin, and we can see a decreasing trend in the removal of dye percentage with the temperature, and maximum obtained at 303 Kelvins. This is because with the increase in the temperature, the bonding between the dye molecules and the adsorbent surface decreases, and the solubility of the methyl violet onto the solution increases. That is, the solute-solvent force of interaction becomes stronger in comparison to the solute and the adsorbent surface. And to conclude it, we studied the sulfuric acid treated biomass, and we evaluated it as a better adsorbent for the removal of methyl violet dye. The adsorbent studies were carried out as a function of the parameters like pH, adsorbent doses, contact time, initial dye concentration, and temperature. The maximum adsorption was found to be at pH 8, and it showed monolar absorption, which we found from the Langmuir model, and it was estimated to be at 98.57 milligrams. We have used these references, and thank you. Any queries?
Anybody has questions? I got a question here. So the dye you have studied is with reference to textile mills, right?
Yes.
Okay. Now, what sort of typical pH and temperature you see in textile mill effluent, and how does your work relate to textile mills that are in India? Did you get my question?
Sorry, sir.
Okay, now you looked at, it's a very good work, a very interesting work, you presented very nicely, thank you for that. So I'm trying to find out what sort of temperature do you typically see in a textile mill effluent, what sort of temperature and pH you see, and how does your work relate to that one?
So we have carried out this experiment at 30 degrees Celsius, and that's ambient temperature. And as chemical engineer, we always root on the 4 points: space, time, energy, and matter. And as we are concerned with low energy consumption, we have used low temperature for a cost-effective method of removal of dye. Less energy consumed because of use of hot air ovens at only 30 degrees Celsius, so less energy consumption. That's our motive.
Was your dye you have studied is from textile mills, right?
Yes, sir.
So that dye you have studied, it is for textile mills, right? Textile mill effluent?
As well as in printing and
Okay.
as gram stain, it can be used in, yeah.
Okay. Now my
Any
question is, what's the typical temperature you see in effluents coming out from those industries? pH and temperature. Relate your work to the real world. I'm just trying to find out because I
So
do not
it's
know
low
about
pH.
that. pH and
Yeah, it's
temperature.
low pH.
Okay.
So it's less than 8.
Less than 8. So then your system will work at that point because looks like if you go to 7, 10, then only it reaches saturation, right? At 10.
Yes, sir.
Okay. And did you also find out what is the absorption capacity of these things? Thomas,
Pardon, sir?
did you find out the absorption capacity, maximum absorption capacity of this biomass?
So it's found in... Yes, so we found that to be a 98% removal. I mean 98.8.
Okay. And also you said you used Langmuir, right? Did you also use any other isotherms to check?
So we use incubator shakers, UVB
No,
spectrophotometer.
No, I'm talking about isotherms. You use Langmuir, right?
Sir, so we use Langmuir.
So only one, or did you use any other isotherms to check whether they
Yes, sir.
also feed well?
So we check for Friend-Lewis and Temkin even.
Okay.
And the...
Okay, thank you. Yeah. Anybody has any other question?
Thank you.
Thank you. They pick up really well.
এটা স্লাইড শেয়ার করে দেন
Yeah,
বন্ধ হয়ে
that's
যাবে
right.
কেটে পড়ে যাবে আমি বলবো কেন একটা সরু করে দিয়া বস্তু আহি আছে তো
তাকেতো মানে আকৌ আগৰ
আনিবলটো ৰেজিষ্টাৰ্ড হৈ গেট কিপাৰ
Go ahead.
কানেকশ্যন কৰিব
Good morning. I'm Amanda, and I'm an undergraduate research assistant. And today I will go over the IO studies to evaluate the engineering nanoparticles. So first I'll go over some background information on the impacts of nanomaterials, and then I'll go over some of our present studies, and lastly some of our future plans. And at first I'd like to acknowledge USDA, the National Science Foundation, North Dakota State University, the Nanoenvirology Research Group, the Civil Engineering and Architecture College, and UCITS and Salem Engineering College. So this is a list of some of the engineered nanomaterials, such as carbon nanotubes, fullerenes, titanium oxide, cerium oxide, zinc oxide, nanoparticulate, silver and gold, and then silicon dioxide, quantum dots, and NZVI. Some of the impacts that have been studied, such as impacts on fish, they showed like some accumulation of silver nanoparticles on sheep's head minnow gills, or like the accumulation of silver nanoparticles on zebrafish embryo, and like they also showed that there was a slower hatching rate. And I've also shown some of the bioaccumulation of copper oxide nanoparticles on carp gills and intestines and liver. Some of the impacts of engineered nanomaterials on insects, they've shown the bioaccumulation of titanium oxide in Arctemia nuclei, the accumulation of like nanotubes on fruit flies, and also the bioaccumulation of iron oxide on C. dubia. And then with the impacts of engineered nanomaterials on plants, you can see on the roots how some of them bioaccumulated on the roots, such as in that red spinach on the upper left. And then they also have shown some morphological impacts, such as the multi-wall carbon nanotubes on the red spinach, and on the radish plant, the copper nanoparticles, as well as like the zinc oxide nanoparticles on peanut seedlings on the bottom. So some of the dangers of engineered nanomaterials is the bioaccumulation, and like that's how it can also like enter the food chain. So like on the picture on the bottom, it shows how some algae may absorb or eat some like nanoparticles, and then plankton, after they consume the algae, will also have nanoparticles, and that just moves up the food chain. Engineered nanomaterials behave differently from the bulk material, such as the picture in the upper right-hand corner shows, like the difference in color. I guess the size goes down, and also like the properties will change. So with food safety, we have to check for like the immediate poisoning with nanomaterials, bioaccumulation, and then any long-term genetic changes. So that's where our study comes in, is we want to understand the interactions between engineered nanomaterials and plants, and then relate this to food security and making smarter engineered nanomaterials. So as far as the study, we have in vivo studies, in vitro studies, characterization, genomic studies, and molecular modeling. Plant sciences is looking into the genomic studies and the in vivo studies, and civil engineering is doing in vitro characterization and molecular modeling. So the two nanomaterials that we are focusing on are carbon nanotubes and zinc oxide, and specifically we're focusing on the single-walled carbon nanotubes. And then the two plants that we'll be focusing on is spinach, which is a dicot and a dryland plant, and then rice, which is a monocot and a wetland plant. However, studies with these will take a long time, and so we wanted to produce an environmental standard that has been used with other nanoparticles and other mediums to start. So I started with the allium studies. So with this, onions are grown in a nanoparticulate suspension, and then their chromosomal abnormalities and root cell mitosis is studied after 2 days. And at first we started with the original test, which was to put a nanoparticle suspension in a test tube and have the onion grow there for 2 days. However, we found that the nanoparticles were settling out, so then we switched to an aerated allium test so that the nanoparticles would stay in suspension. So why allium studies? It's a short amount of time since onions are very fast growing. The alterations in root formation and the mitotic cell cycle indicate whether or not the medium that the onion is growing in is toxic or not. And it is a sensitive environmental test which correlates to many other standardized tests. So this just shows mitosis. So for the majority of the time the cells are in interphase. But then when they need to duplicate to form more cells, they'll go through the mitotic cycle. And this is from another paper, and it shows the first three on the top are the normal cell cycles, and then below it shows some of the abnormal cell cycles, such as D is like sticky metaphase, or like E and F have chromosome bridges and chromosomal fragments, or like G and H have vagrant chromosomes where they're not really going with what the rest of the cell is doing. So this is a picture from our work. This was taken from an onion that was grown in deionized water. And then here are some of our preliminary results. So with the zinc oxide, this was grown in a zinc oxide solution. And after 2 days, we made a microscope slide and looked at it. So we found, again, this is preliminary, we found like vagrant chromosomes. So like the image on the left is my image, and the image on the right was taken from the papers to kind of compare it. Or here we have like sticky metaphase. And then multipolar anaphase. You can kind of see where it's not just going to the 2 poles, but it has like a 3rd pole in there. And then with carbon nanotubes, again, these are preliminary. We found, like here, you can kind of see where it's starting to, you have the 2 separate, like it's getting ready to split into 2 cells, except for it's not actually splitting, but you can see where there's the 2 nuclear envelopes beginning to form. And then here again we have the multipolar anaphase. And then here it's a binucleated cell. Like you can see there's two nucleuses inside the one cell, except for like one is now going into mitosis while the other one is still staying in interphase. And then again with sticky metaphase. So in summary, the chromosomal abnormalities in root cells grown with zinc oxide we found to have multipolar anaphase, sticky metaphase, and some vagrant chromosomes. And then with the carbon nanotube suspension, we found multipolar anaphase, some binucleated cells, sticky metaphase, and chromosomal fragments. So with future work, we'd like to continue IM studies for different nanoparticles. And we'd also like to study the effect of the nanoparticle concentration on like the increase or decrease in the chromosomal abnormalities. And we'd also like to look at mitosis in other plants as well, such as like spinach. And then here's a picture. Do you have any questions?
Do you have questions from Assam Engineering College?
Yeah, my question is, since you are studying the effect of toxicity and trying to find methods to remove the toxicity, can it decrease the working efficiency of the nanoparticles? If toxicity is removed, can it decrease the working efficiency of the nanoparticles?
Can you rephrase your question? Can you ask it again? We didn't get it properly.
Since you are studying to remove the toxicity of the nanomaterials, can removing the toxicity of the nanomaterials decrease the efficiency of them, working efficiency of them?
Okay. Maybe I can take the question because Amanda is not exactly working on removing toxicity. She is trying to study the toxicity, how toxic the materials are. Okay, that's what she is doing. We have. We will be studying removal of toxicity maybe later on, but as such, we do not know how the nanoparticle behave at this time. There's a lot of unknown things are there. So that's why you are trying to find out whether this nanoparticle really affect plants. So we are looking at spinach, that is paleng, in India, and rice, than. So those are two species we are studying right now to find out effect, how they are going to affect the genomic level. So that's our idea. Now, in terms of whether if you remove that toxicity, whether they'll be effective or not, that's an altogether different question. They're toxic because they're very, very reactive. They're toxic because they're very reactive. If you make them non-reactive, of course, there will be no nanoparticle characteristics. That will be gone. So we still want to use the nanoparticles, but we do not want to have the toxic effects left. That is our idea. So that's why you're studying what are the impacts that you're going to have, and whether we can go back to the designer of the nanoparticle and tell them, these are the effects we have. Can you design a better nanoparticle such that we do not have these defects? Okay.
Excuse me, sir, I have a question.
Sure.
So what is the basic idea of choosing allium as the study subject?
Why have you selected allium?
Okay. Onions are fast growing, and it's kind of been used as the standard, so there's a lot of data already on onions, so we can compare it with other words.
Did you hear that?
So we didn't get the answer, sir.
Can you speak louder?
So onions are fast growing, so we can get results quickly, and also there's been a lot of papers and research done with onions on other suspensions and other mediums, so we have works to compare it with.
Okay. Okay.
So basically, onions are so fast growing that you can get your results within 2 days. With any other plants, it takes a long time to do it. So this is pretty much standardized test. Anybody who worked with plant cells, chromosomes, genes, they always go for this study with other materials. But people have not done a lot of work with nanomaterial.
Okay. Thank you, sir. So we'll be presenting our next slide with Abhinav Bhattacharjee from Civil Department, Assam Engineering College.
Please make sure to mute your video before starting the presentation. Please mute your video so we have a better chance of not getting disconnected.
Abhinav or Sinmoy, once you start your presentation, once we see both of you, then you can mute your video and only share the content such that we can get the content better. We'll still listen to your voice and get your content. We have not seen both the presenters though. If both the presenters want to, be there. Yeah. We can see both of you now. You can now mute the video. Thank you. You can now mute the video and share the content. Not before. Okay, that's good. That's good.
Can you see the slides?
Yeah. Yes, we can.
Go ahead. Okay. So the presentation that we are going to make today is on goodness of fit test for few probability distribution functions with reference to the river Pagladia in Assam. So what we'll come to know at the end of this discussion is which method is more suitable to the area of study. Before starting, I'd like to give a brief introduction on flood. Flood, as we know it, is the unusually high stage in a river, normally the level at which the river overflows its banks and inundates its adjoining areas. So a hydrologic process resulting from a number of component factors as it is, the determination of flood peak estimation is a very complex process. The methods to estimate the magnitude of the flood peak are the rational method, empirical method, unit hydrograph technique, and a flood frequency analysis. In our case, we have adopted the flood frequency analysis. Moving on, I would like to narrate the salient features of flood frequency analysis. It is determining the frequency of likely occurrence of hydrological events, determining the flood discharge magnitude, which will exceed the selected threshold discharge in a given period of time known as the return period, and it is based on probability and statistical methods. Now, we come to the practical importance. We all know the devastating effect of a flood. It can destroy drain systems, it can destroy buildings, and also the toxic materials are dislocated and get released into the environment. Here we see a picture depicting the serious problem of floods in Assam. The severity of this recurring problem every monsoon has caused havoc in many parts of the region. Moving on, we see another picture which shows a family stranded outside their home because of flood. And next we come to the necessity of finding the most suitable probabilistic model for this. So no single probability model is considered best for global use. It depends on a number of factors which is specific to the region. So this is the outline of our research, which mainly consists of 4 main points. First one is to suggest the best suited probability model for river Pagladia in Assam. Estimate the design discharge using Gumbel distribution, log normal distribution, and log Pearson type tree distribution. To develop applications of software for Gumbel, log Pearson, and log normal methods. And lastly, to obtain the best suited method for computation by applying the statistical d-test method. These are the assumptions that we have considered in the flood frequency analysis. These are the methods that were used by us during our study. And this is an overview of the region in which the study was conducted. So Pagladia is an important north bank tributary of the Brahmaputra river. This tributary originates from Bhutan Hills, passes through undivided Nalbari district, and finally connects with the Brahmaputra river. To utilize the available water as well as to mitigate the flood hazard, a number of dam projects have come up. So this picture shows the region and the Pagladia basin, and this is a map of the basin. And these are the climatic conditions that are prevalent in the basin. The rainfall is higher during the monsoon seasons, which extends from May to September, and the relative humidity in monsoon months varies from 79 to 85%. Here we come to the main part of our study, which was done on a C++ platform. We see the flow charts for the different methods, for the 3 different methods that we applied. First one is for the Gumbel method. We enter values of T and N. T is the return period and N is the sample size. And based on the value of T, whether it is greater than 10, in between 10 and 100 or greater than 100, the following flowcharts were computed, and it was performed in C++, and the estimated flood discharge were computed. Similarly, this was done for the log Pearson method and for the log normal method. So the difference between these 2 methods we can see is that here only the time periods, return periods of 10, 2, 10, 25, 50, 100, 200 and 1000 years were considered. And in log normal method, the CS, as you can see, the coefficient of skewness, that is 0, and therefore it is omitted here. So these are the presentation of the results and discussion. For different return periods of 2, 10, 25, 50, 100 and 200 years, the estimated flood discharges are computed using Gumbel method, log Pearson type tree method, log normal method. And this curve was computed. The black curve that we see is the best fit curve, having the equation y is equal to minus 351 natural log x plus 166.3, and the blue curve that we see is from the observed discharge. So this was the formula that we used to compute the probability. This Pm is equal to m divided by n plus 1, where m is the rank and n is the sample size. And the determining formula which we use to find out which method is more suited for the Pagladia basin is the D-index test, and the formula can be seen here. And to find out the D-index for the 3 methods, we plot the data as here for different return periods. And we can see that the D-index has been computed for the 3 methods. In Gumbel it is 24.253, in log Pearson it's 16.916, and in log normal it is 31.550. And this is the curve showing all the 3 methods and the power graph, and it shows the comparison between the 3 methods, and we see that the log Pearson type tree method has the lowest value of D, and according to the D-index test, the lowest value of D determines the method which is the most suitable. So from this we can conclude that the least value are found for the log Pearson type tree method, and therefore the most fitting method for the Pagladia basin is the log Pearson type tree method. Thank you.
বন্ধ হৈ গৈছিল নেকি বন্ধ নাছিল
Are you ready for some questions?
Is there any?
We have some questions here.
Yes. Could we have the questions?
Okay.
Yeah. How many stations did you do this analysis? Is it for one station?
Could you please repeat the question?
Flood frequency analysis, did you do for several stations or only for one station?
It was one station.
I see. Okay, you have plans to repeat it on several other stations?
Yes, sir.
Yeah. I think that will strengthen your conclusion. You know, log Pearson type 3 is often used, very popular, and your results show that, but I think it will be a good thing to try it out on several stations.
Sir, here we would like to introduce the guide under which we performed the project. He is Dr. Vipul Talukdar, sir. He would like to answer the question.
Excuse me, but what exactly the question is?
Just wondering, on a probabilistic basis, if you want to make the conclusion, it will be better to do this on several stations.
Pardon, is it the number of stations?
Yeah. Yes.
Yeah. Exactly the thing is that the whole analysis is based on a historical inflow series. So if we measure the historical inflow series in some other different station, it will be almost same. It exactly may not be same, but it is almost same. So that is why it is done only in single station.
Okay.
Thank you.
Thank you, sir.
Thank you. Now, if anybody has a general question about NDSU, or if we have a question about Assam Engineering College, maybe there is an open forum right now. If you have any questions about the presentations or anything else you want to ask.
Anyone have any question regarding NDSU?
Let me quickly introduce some of the faculty members we have. I don't think right. Yeah. Okay. We have few faculty members here. Dr. Padmanabhan just asked a question. Dr. Padmanabhan is the faculty professor here at Water Resources, and on the other side, Dr. Kadi. Dr. Kadi is a faculty member. He's a professor in geotechnical engineering. So, and we have the undergraduates and undergraduate students on the back side, and they work in different areas. So feel free to ask questions in any area related to engineering or science, and any other questions you have for the other faculty members as well. Do you have any specific questions? Okay. Now, I think we had a very good presentation. I really appreciate those presenters from Assam Engineering College. It's a very quality work you have been doing out there. We really appreciate that. So this is a this is a month of global awareness, so I think it's a very good, month that we have this, conference. So hopefully we'll be able to continue this effort with you and other groups in the future. So with that from our side, if anybody from your side want to make any concluding comments, so please go ahead, and if you have any questions specific, go ahead and ask. Thank you.
Excuse me? Excuse me, sir?
Yeah, go ahead, we can hear you.
I have a query. What are the research opportunities available in NDSU for foreign students?
Okay.
Well, I think that tremendous opportunities for international students to come here for graduate studies and in a variety of areas. So this is a...
Can you hear us?
Can you hear us?
Maybe you can go to the other.
No, sir.
Okay.
Okay, hold on. Okay. Yeah. Yeah.
All right. Can you hear me now?
Yes, sir.
Okay. Well, there are tremendous opportunities for research at NDSU. NDSU is a very comprehensive university, which means that we have very strong engineering programs, science programs, and also humanities, social sciences, and so on. So we have a lot of opportunities for research and creative activities at NDSU. Now, specifically in engineering, we have all major areas of engineering, from mechanical to civil, electrical, and so on. And the people in the College of Engineering work on a large number of interdisciplinary programs. They work on very cutting-edge programs. So whether it is nanotechnology, nanomaterials, environmental conservation sciences, or high-end computing, so there's tremendous amount of research going on here at NDSU. What I would suggest is go to the NDSU website and go to the individual departments, and most departments will have web pages which describe the current research that's going on in various areas. And then feel free to send emails to individual faculty members, and we can answer your questions. And we would also like you to go ahead and apply for graduate studies here at NDSU, whether it is master's or PhD or whatever you are interested in. So the first step would be to take a look at our websites. Now you know a few of us here at NDSU. You have Dr. Bess Barua. My name is Dinesh Katti. Last name is Katti. Or other people. You just send emails, and most faculty members would be happy to respond to your emails and provide you with more details. Any other questions?
We cannot hear you.
Your microphone is muted. You have to unmute it on the screen. There's a little microphone symbol. There we go.
Okay.
Go ahead.
So thank you, sir. No more queries.
All right. Thank you. Okay. Okay. He has it.
Can you hear us, sir?
Yeah, we can hear you well. Go ahead.
So do you have any queries from NDSU for AC?
Any questions from here, this side? So, do you guys typically take GRE and TOEFL?
Yes, sir.
If you want to really come abroad, those two things are always required. So, you need to really, undergraduate research really puts you in a strong position for graduate studies. So definitely those are the things basically, as Dr. Kani said, you need to look at our website, see which area interests you most, and contact the particular person and that particular faculty member will let you know whether there are funding available for a specific project, or they're in a position to recruit people. In our department, we normally do not recruit anybody without funding. That's why we have 67 students. Most of them are funded students. So that's why we also, many a time you may hear from us that we do not have funding, but that doesn't mean that funding will not come back in another 6 months or so. I think consistency is very important, and your statement of purpose is very important. Obviously, that's where your scholarly, things are reflected.
Thank you, sir.
Okay.
So we would like to introduce two of our faculty members here. The head of the department, Dr. Palasjyoti Hazarika, sir.
Am I live over there? Hello, Asinto, are you there?
I'm here. We can hear you.
Asinto Belpura?
Yeah.
Yeah. It's nice to be in front of you, in spite of being so far. Okay, so we are here, and our students have worked very hard, particularly Ritukesh, Pritish, Kuldeep, and also students of Chemical Engineering Department. This is entirely because of your persuasion. This is the first time that we are having a video conference from our college, first time in the history of this college. And I think I should give credit to you for doing all that need to be done to get this thing live today. And this will be our whole college, our student, the college community is thankful to you and NDSU for making this happen. So very soon we expect to have another session with you, and I know that you will not stop, you will give me a ring tonight for the next session. Let's hope it works out very soon, and the students are now very eager. They are requesting us again and again to set up a studio like you are showing now. They are very inspired, and I am inspired, and we shall take up this matter with the college authorities to get it done.
I think that will really help. Yeah, that will really help staff, because we can talk in terms of research collaboration and others. That will be very good in the future.
Yeah. So we are taking a step in this direction very soon, I can assure you, so that we can have the similar facility here, and this can be carried out further, more frequently, more effectively, more efficiently. So on behalf of Chemical Engineering Department, Civil Engineering Department, Assam Engineering College, a very big thank you to all of you, and let's meet very soon. Thank you.
Thank you.
Thank you very much.
Thank you to all the students in Assam Engineering College who have taken pains to set it up. I know I worked with you, I called you at night, I called you in the morning, so it really took a lot of time to set it up. You really did a lot of effort. Thank you for that. Thank you for all of you guys.
Professor Palas, this is Padmanabhan from NDSU. I think with all the efforts that is going on now, the two institutions should go for a memorandum of understanding. I think that will also facilitate this further, the exchange of students, exchange of faculty, and so on. That's my request.
Thank you, sir. So we'll surely try for a memorandum of understanding between the two institutes. Anyway, I would like to conclude with these words. On behalf of the organizing members, I, Ritukesh Bharali, would like to thank North Dakota State University for their collaboration in our first digital conference. We look forward for such events in the future. Thank you, everyone.